the information, like I quickly showed you, that was easy to mass produce, uses our flat plate technology to use diffuse light, which might come from clouds, use flat panel technology from readily available composites so they could be stronger and lighter, and use high reflectives by silvering the front to avoid any transmission through glass, remember, with that loss. So this type of system would have an excellent technology interface potential and should be good for many uses. And here we see the simple solar machine that we ended up putting together up here in the right-hand corner. Okay? This is completely fabricated at the factory level. These are resin that make up the mirrors in these particular systems. These things are modular, light to work with, and it's very simple to assemble. And what's also good is by just running some liquids through the collector that's out front, we can interact with many, many other types of systems to do many, many things besides just heat water or make hot air. Now, we also know the system is quite effective, okay? This is the big upfront costs are cut back by this very cheap little unit. It has a nice compact design. In fact, it'll fit in the back end of my Prius. It's suitable for both residential and commercial use, and you can see we can generate temperatures, very high temperatures if we wanted to. Here you see 702 degrees Fahrenheit being generated by this system, and that was with an oil flowing through it. Here we see the individual pieces, the mirror holder, the mirrors, and the back frame. All of these easy to manufacture, as we said, and easy to put together. And what it has done is we've combined the attributes of the flat plate heliostat system that I showed you with those of the solar dish concentrators, the very expensive solar dish concentrators. Now, what do you use this heat for? Well, one of the things we'll go over in the course, and one of the things that we've designed our system for, is the fact that there are many types of heat applications that are typically functioned around how hot is hot. If you want low value or ground temperatures, where we're talking under 90 degrees Fahrenheit, we have your pool, using it for geothermal pumps. There's a lot of different simple applications. These temperatures also could be used for greenhouses in the wintertime. At low temperatures, 92, just over the boiling point of water, are many, many applications. Greenhouses, aquaculture, and space heating in your home. And I should include in that space cooling. Even though typically people want a little higher temperature, for most typical cooling, there have been developed some new technologies which can use lower temperatures. Overall, we see that solar thermal has many applications. I say it's green heat. It takes the place of coal, takes the place of burning manure, takes the place of many types of things in many types of applications. Now, as I mentioned, that you can solar assist space heating and cooling with our particular system. We'll teach you about some of the different units that are available, particularly in the chiller units. There are some new technologies that are out there, such as zeolites that evaporate off water. That means they work at the boiling point of water, which is 212 degrees Fahrenheit. Okay, some of these systems allow us to do air conditioning under the summer days, which is something that everybody, of course, would like, as well as doing the standard heating in the wintertime. This offers a wonderful option for people. And again, we also emphasize the fact that our system does not have to be an 100% system. In other words, we don't have to have 100% of our heating and cooling done by this system. And that's another lesson we hope to show you, that sometimes a little bit is just as good as a lot. And here's an example. In my home, I have a solar thermal hot water system. And here's my home in the back. Here's the system. And hot water flows through this small little radiator system in the front. And that little system heats up well enough and is exchanged in this commercial off-the-shelf unit to show how well it interfaces with existing technology. And here is the heat exchanger. And this simple unit saves me between 25 to 33% of my hot water bills in my home in Ohio. Now, where I live in Ohio gets cloudy more often than it's sunny. So the advantages of the flattened era in being able to use cloudy days, and the fact that it constantly tracks the sun are big advantages to this little teeny system. And you'll learn more about these kinds of systems. Also, I have a nice backup in the fact that I already have gas coming into my home, so I shut it down. This way I have a safe, simple backup system that makes my unit work all the time. Now, again, back to using solar. It's not necessary that we have 100% of our heating come from solar to make a project worthwhile. And many times, we can leave in place your existing infrastructure and or use it by interfacing with solar so that we can knock off a certain portion of heating and cooling bills. Now, another application of solar thermal that we'll probably go into in the course is agricultural thermal applications. This is where we just take the hot and use it for different things. Right here in Louisiana, we're studying rice drying with a solar thermal collector. Rice has very, very particular conditions that it needs to be dried under. And two, they affect the cost. The temperatures are moderate. 160 to 7 degrees Fahrenheit is almost the maximum temperature that you want to go into a system. That's easily achievable in a solar thermal collector. Okay? In New Zealand, people have used solar to warm up the water. And here, they only needed small temperatures, 75 degrees C, to grow freshwater prawns. These are extremely valuable. They were getting 14 to 18 tails in 9-month period of time, and they sold for about $17 a pound wholesale. You can see this is a great little business that was made a good business by the fact that solar thermal energy could be used to maintain their ponds at appropriate temperature for ideal growing conditions. Now, other companies also use simple solar heating systems. And I put this slide in here, one, to show you more things that we'll talk about in the class, but also for you to understand that major companies use simple solar heating systems. And this list is from 1988. And I also want you to note that the temperatures needed by most of these companies were extraordinarily low. Not the high temperatures you think might be necessary. So therefore, a system would work in Indiana for parts washing because they only needed 54 degrees. And I want you to understand that your system can be modified or looked at to see whether or not you can do solar heating or cooling. But in the course, you will learn whether or not that's true as well. Now, this next slide is only to show you that there's other topics at Energon University. I've stumbled and bumbled through this talk about solar thermal, and there'll be other talks on other topics by other individuals. I'll be talking about the recharge when this project comes on to be taught, and it's based on the biochar. But I want you to understand that these are the types of things that are available to you at Energon University. This last slide kind of gives you a picture of what we're trying to do here. We want you to break out of your shell and learn as much as you can about energy and what you could do. We want you to change your thinking that there's only one path in life. Either you win or you fail. Successful people know in reality you have to stumble your way along, and if you keep up the persistence, you get there. And lastly, no matter if you're curved or you're flat or whatever, you can focus on getting to the right place at the right time. Energon University hopes to help you get there. We hope you tune in, listen to our courses. We hope you contribute to help us grow and to help the world. Again, I thank you. My name is Dr. Richard Sapienza.